in the last session, I had a problem. It didn't record for me. Hopefully with this session, I'll be able to record everything. So I couldn't upload the last session. I'm so sorry about this. There had been a technical problem. This time I'm gonna make sure that everything we talk here is recorded, and it will be hopefully uploaded to YouTube, so you will be able to watch it. Last time I had the same intention, but somehow there had been a problem and it didn't record it. Today I'm going to talk about the process activities, which are concerning all software process activities that we discussed in the last lecture. If you remember, these were the specifications, the development, validation, and evolution. These are the process activities that should exist in every single software development model. So if you remember, we said that regardless of which process model you choose, you will need to apply these process models, the process activities, sorry, into the model that you had chosen. These are the specification, development, validation, and evolution. Just to basically touch them down, specification is where you do the requirement specifications. When I say requirement specification, I mean the requirements that for that project to exist. Normally, we have a process called requirements engineering, and this is divided into three areas: non-functional requirements, functional requirements, and domain requirements. Now, non-functional requirements are features, let's say, that is essential, they are essential for a system to exist, such as all the features that fall into the SAMET category. You remember SAMET in the first lecture? We said the security, accessibility, dependability of a software. Remember, efficiency of a software is it's an integral part of it. We have to make sure that these features are always supported in the software. So any requirement that falls into that specific category is actually listed under non-functional requirements. So these are requirements that are divided into further requirements in order to satisfy it. So there shouldn't be only one requirement that will provide the security. There are probably 10, 15, or whatsoever. And if you support all 15 requirements, then it will go and support the non-functional requirement automatically. So this is where specifications are done. Another important point of specification is requirement analysis, which is where you do the the feasibility report. I would like to ask you whether or not you are taking a project management course this term, 401. Are you taking that course? Anyone, or are you not taking it? Can you please respond to me in the group chat or just by talking? 401, project management. No. Tara said no. Anyone else? Are you taking? No. Okay, one person is taking, Rabasa. You can see that. Don't know who you are. So if you rename yourself as name and surname, I will appreciate that. Okay. So some people are taking, some people are not. That's good. What you are doing essentially in 401 is constructing a feasibility report for your project that you're gonna do in 402. So this is kind of like your specification phase. You try to understand what the problem is, how you can approach that, how you can solve the problem, and what kind of steps you need to do. What is the market value of the research you are doing? What is the market value of the project? What kind of steps, requirements, hardware and software wise what is the money budget that you will need. These are the kind of like part of the specification requirements, which is one in the feasibility study, to analyze whether or not the work is feasible. So these are all part of the specifications, just to talk in general. The development part consists of both design and implementation. When I say development, I don't only mean sitting down and coding. So people do not sit down in front of a machine and code all day. Anything that goes into documentation, design, by design, I mean designing the system itself, falls under this category. So development is not only programming, that is part of implementation, but it also considers a lot, such as designing the architecture of the system, designing how the system would interact with other systems, the UML specification, the UML diagrams that you draw to show how the system will function and support what it's supposed to do, which modules would be supported with the software activities, software development models. Are you going to strictly follow one model to organize and manage it, or are you going to use more than one model? Is it going to be an agile development? Is it going to be a plan-driven one? All these factors affect the process activity. Validation now changes quite a lot compared to the past experiences. In the old days, what we did was we followed a step-by-step approach. So basically, we needed to analyze the software. The software was designed, developed, and tested. Nowadays, validation is kind of like done with the development as the development goes on. It is not regarded as a separate step usually. It is a concurrent activity, just as we saw in the last lecture. So specification, development, and validation can be concurrent. And what we do in here is that the modules, as you develop them, are tested by the developers themselves. And then you do a unit testing. And having done so, you release a version, which is called the early alpha version, which is only tested by the developers and then it will be tested before it goes to an iterative process again, before it goes to the potential users. And then the potential users test the software, which is called the beta testing. And hopefully then the software will be released. So this is like a proper approach that we follow, particularly for interactive software, but not every software follows this procedure either. Majority of the mobile development, for example, is only tested on the developer side or with a small group of users before it is released. And what happens then is that the potential users test the software, report the bugs, report their feedback, and then the developers continuously look at the logs, look at the user stories to develop it further. And this is how validation is done. So it changes quite a lot according to the model you choose. But regardless, it is a step that should exist. Finally, evolution is the step that should never ever stop. If you stop evolution, you risk your software to disappear from the platform, from the industry. Evolution is a step that should continuously encourage development and validation. So basically, you get feedback from the user, you understand your user base more and more as your software is being used, and you should adapt to the needs of the user requirements. So from here, you go back to the beginning. You go back to generate new specifications, which then you create more development reason for the software, more features to be developed. And of course, this results for more validation. So it is kind of like a step that follows up and creates a circle. So in the old days, we would regard software as a step-by-step approach. so that it will come up, at some point, and it will be like a flow chart. So it's like one by one, you go like this, and at the end it finishes. So it's like starting point, then continue, development, validation, evolution, and done, finished. Now there's a finish. So there's a start, there's a finish. This is no longer true. There is no such thing as a finish point for the software, because as you finish the software itself, you are risking that software to be disappeared. So our understanding of software design is now a circle. So it should go like this. So you do the step for the specification, you do the step for development, validation, evolution, and evolution connects to more specification, and it goes in a cycle. And if you somehow want to break the cycle, you risk your software to disappear. That is our understanding of the software world now and the process activities. Now I'm going to give a small break now, not a small break, but a fresh of air if you want to ask questions before I continue further. Anything you didn't understand, anything you would like to ask me?
Excuse me, can you hear me?
Yes, a bit louder, please.
I think there's something wrong with my mic earlier. I just wanted to ask the reason you shifted the class, because I actually have another class today, starts at 10:30 till 12. So is this going to be every week like this?
No, I will try to stick to the lecture hours, okay? But there was a kind of like a circumstance I have to deal with today, so I shifted on Fridays. Normally, I don't have a class on Fridays. I don't even see students, but you see that we are all under kind of like very stress, very difficult times. So I couldn't manage that time for myself. I had another meeting that I have to do at that specific time, because I need to understand how I'm going to assess you. I need to understand what's going to happen next month, okay? And to be honest with you, I don't know. I'm trying to learn how I'm going to cope with this. I'm trying to learn how long these classes will continue and stuff like this. So just we are at the first week, okay? Don't expect everything to work perfectly from the first week, because we are not supposed to. I'm not an expert in online education. I have done online education before in England, but I'm not an expert in it. Just like you, I don't have much experience. So I am trying to understand how I can manage this, okay? And it takes time. So this is why during the lecture times, I was busy doing other things, and that's why I shifted the course. But next week, when I announce the lecture times, I will try to stick to the lecture hours. Another important point that was given to us is that we are supposed to do offline sections for you. This is the suggestion given to us from the rectorate office, is that for classes such as this, we are supposed to upload videos, not do online sessions, just upload videos and briefly log in to the big blue button to receive questions from you. And that is the procedure that is suggested to be followed. But for this specific course, I don't think that is very efficient. For programming courses, I think it will work really well, because people can watch the videos in advance and they can come and ask questions. So that works very well. But for an interactive course like this, when I can explain it and people should ask questions, it's difficult, because I can explain something in the video and you want to ask a question, but then because it's not really synchronous, you can't ask a question. So it takes time to adopt, in short, okay? So give us 1 or 2 weeks to get adapted to the system, and I will try to stick to my timetable. Does that answer your question?
Yes, that's okay. Thanks.
Okay. But sometimes, as you can see, there are circumstances that I cannot follow the timetable, because As you know, this is not a regular situation. Okay, so and the best thing I could do, if you cannot attend, the best thing I could do is to record each session in Zoom, and it allows me to record videos up to 40 minutes. So after 40 minutes, I have to cut it and re-invite you, because I'm using the free version of it. And also, it doesn't let me pay for some reason with the Turkish banks. I tried to pay, I tried to buy the software, but it just doesn't accept my credit card for some reason. I don't know why. So I'm just sticking to the free version, which only allows me to record up to 40 minutes. So after 40 minutes, I gotta stop this video and re-invite you, just so you know. Any
Okay.
other questions? No. Okay, let me continue. In the software specification part, as I already discussed, this is the part that you understand what services are required and what are your constraints. Now, this is the part that I didn't perhaps mention, but the constraint part is also important, because this is where you understand what you have to do and what you shouldn't do. Okay, it's also important to let people know that what you are not going to do in the system, because they might automatically assume that something is going to happen, and some features are going to be supported, such as assume that you're going to do a mobile program, but at first stage you are only going to do the Android version, and at a later stage you plan to release an iOS version. But because people didn't understand that, they might automatically assume that, oh, they're going to be released at the same time. So it's always a nice idea to give a clear constraint of the system to let the user base understand what are the limitations. Okay, and just because you understand that, it will be kind of like more grounded, because you know what your software would do. So that always gives a good impression. Okay, you identify the operations, and you define the limitations of what you're going to do, and it just makes a clear development path. As for the specifications, we already mentioned that the feasibility report, which is the market research, and what is the market value of the research in there, the base documentation to identify what the system needs in order to satisfy the requirements of stakeholders as well as the users. It's not only stakeholders, I think also the users are quite important at this point, to understand how many potential users you have, what kind of what is the need in the market value, what is even the estimations that you can create in a year or so. These can all be part of the feasibility report. There are some guidelines to write feasibility report, and you're going to see a guideline documentation when you take a 401 class, which is the project management. But these are actually very vaguely defined. So for each project, these guidelines change. Some projects have very, very strict hardware requirements, for example. So if you're gonna design an embedded system or an image processing system for a drone, it is gonna be quite different than a mobile development project. And again, if you're gonna develop a virtual reality application using a game tool, that is gonna be completely different than an e-commerce responsive website. So these requirements will change according to the project itself. A website would not consider hardware requirements that much. It will be more focused on the software requirements, where a drone project will heavily be considered on the hardware requirements for that specific software, because you will need to use some external hardware devices such as Raspberry Pi or whatsoever to support your software. So at the end of the day, your feasibility study is a guideline. There could be a guideline for documentation, but there is no right or wrong way to write it down. Okay. As long as you address to the market requirements, you generate a very clear report. There is no correct way to present to write it down. All that matters is your presentation. Yes, Darlington, I'm gonna unmute you.
Yes, I wanted to ask a question about software development, project management specifically. I'm actually taking a course, Information Systems and Analysis, this semester, and it's basically talking about the job of a systems analyst. So everything we're talking about right now in the software development lifecycle, whose job specifically is this? Is it a collection of people? For example, if you're an engineer just starting off in an organization, are you actually involved in these processes of getting the project ready, the specification, the verification, and all that? Which aspect of it, as let's just say, as a new employee or as a fresh graduate, which aspect of it are you more likely to be involved in?
Okay, let me tell you this, that there is no system analyst anymore. I would seriously doubt you will find a system analyst position at this time and age specifically for it. Okay, every 10 years in the software world, some jobs disappear, some others emerge. This is why software is the most rapidly developing, rapidly changing industry. Like 10 years ago, 15 years ago, we didn't have UX researchers, for example. Companies didn't require user experience researchers or talent researchers or, let's say, data science people. They didn't require any of these things. Okay, nowadays these are the top jobs. Anyone who understands from machine learning, data science, these are the most well-paid jobs in our industry right now, and they didn't exist 10 years ago. Okay, so you need to understand that, yes, they are teaching you system analysis and design, but there is no such position, as far as I know, as system analyst anymore. What is being expected from the developers is to take more than one hat at a time, okay, and be more versatile to change the role. If you want to be a software engineer, of course, you're going to deal mostly with programming and development, but you will also be expected to be presentable. You will probably be expected to attend to some meetings, to show stakeholders what you require for projects, at least to your team leader in a big company, to present what you need for this project, what is the market research, what kind of documentation you need to create for the system needs, and then they will come around, take your opinion, and present that to the stakeholders, to the people who's going to support this project, who's going to pay the money for it, for the development, who's going to pay your salary. And it's kind of like a negotiation. Okay, so there is no explicit job that will only do system analysis anymore. I don't think so. I think a system analyst should also understand from development in order to grasp the idea of what exactly the value of the software, how it will be, what kind of needs it requires to be developed, and so forth. So this is why I think they are teaching you more than one aspect, because when you go to the industry, you should be fond of more than one aspect of the development. It's only sitting down and writing some code in Java or Python or whatever language you're gonna choose, but it's more about how you deliver the system, how you meet with customer requirements, and whether or not you are actually earning money to that stakeholder. Because at the end of the day, they only care about if this is making profit, and that is the most concern when it comes to the satisfaction of the stakeholders. They will only care about profit and nothing else. So you need to understand that, and you need to generate the report according to a way that it will actually convince them that this is going to be a project that will, at the end of the day, profit them. Okay, so you are basically taking more than one cap. I do not believe you will find a position explicitly for system analysis and nothing else. So please do not be under the impression that you're going to work in a company and just do system analysis and nothing else. That's not how the industry works nowadays. You need to take more than one cap, which means you need to be versatile and take more than one job at a time to survive in there. You need to understand from developing the software as much as creating a specification document or design. Does that answer your question?
Yes, it does. Thank you.
Okay, cool. So I'm going to continue with specifications. I have around 8 minutes. So I'll let you know when it's closed and end the session and create a new one. So I'm going to continue with this. So when we divide the specifications, we have 3 titles in general. Of course, specification is not consisted of only requirements, but these are the main concerns that we need to focus. We do a requirements analysis. As Darlington said, this is the place that you learn quite a lot about system analysis. You observe existing systems and what you can put on the top of it to address to the customer needs. In the requirement specification parts, you have 2 types of requirements. Basically, these are user requirements and system requirements. We're going to touch to this topic in the upcoming chapters. We have a specific chapter called requirements engineering, and there we will actually investigate user and system requirements together. Okay, so all this specification at a later stage will be a different chapter, completely dedicated to look how requirements are formed. And finally, the requirements are validated either at the end to make sure that the requirements before the requirements documentation is completed, or also in the validation step. So you carry up the requirements to other steps as well, just to take them. So it's like when you do the validation, you can come back to the requirements documentation and cross-check them just to look whether you satisfied the requirements or not. So it's not like you do the requirements and completely forget them and move to the next stage. When you do the actual testing, you can create a series of lists and cross-check them while you do your testing. So at the beginning, let's say you wanted to support the software performance to be under 6 seconds after user interaction. And when you test the software, you can actually test this in every single step. So creating a requirement such as the software should not take more than 6 seconds to run after user interaction is a non-functional requirement because it affects the overall performance. And when you do the testing, when you test this specific feature, you test it with submitting a button. You can test it from the menus, just different kind of interactions to see whether or not it's going to pass that 6 second threshold in every single circumstance to make sure that you meet that requirement. So in short, when you define your requirements, you don't define them and forget them. You actually return back to them at the validation just to cross-check them. So this is the layout of requirement specification. So there is a step called elicitation and analysis where you do the initial analysis for requirements, and having done so, you move into the requirement specification where the requirements are actually defined, and then the requirements are briefly validated. And as you can see in these steps, that you can always go back. It's not like you define something and it just you leave it there. You can always go back. You see the arrows. And within the elicitation, you generate with each step. These are the basically the reports that are generated in each step. So when you do the elicitation and analysis, a system description report is created. When you do the specification, user and system requirements are delivered. And once you have validated, the requirement documentation is complete. So this is where you complete the requirements documentation now, where you can say that this is your feasibility study basically, and that is where you're going to base your project on. Okay, so with each step, a report is generated, as you can see. This is a normal procedure of a big project, but as I said, it doesn't fit always to every single project, such as in agile development. Majority of these steps are taken as concurrent. So instead of generating separate reports, they try to complete these steps as soon as possible because they don't want to spend too much time on spending for the generation of the reports. So it's kind of like, oh, I'm just going to do this as soon as possible and generate the report at the end, this one, and skip to those ones, just make them like some scratches on a piece of paper, generate a brief report so that we have something to work on. So agile development aims to develop the software as soon as possible by skipping the documentation. So there is no explicit steps such as this for creating documentations, but rather you try to skip it as soon as possible to jump into the development, which is the design and implementation of the software. Right, I'm gonna stop now, and just before I pass to software design and implementation, I'm gonna end the meeting and invite you again on a big blue button so you can join again. I have around 3 minutes before my time. Do you have any questions before I stop here?
No, it's clear.
Okay, cool. I'm gonna end up the session now, and I will re-invite you. So please go to big blue button and let's continue our call.